this problem, we have two pianos. Each sound the same note simultaneously, but they are both out of tune. On a day when the speed of sound is given to be 343 meters per second, piano A produces a wavelength of 0.769 meters, while piano B produces a wavelength of 0.776 meters. How much time separates successive beats? So we want the time between successive beats that will be produced due to these two sound waves, which obviously have very close frequencies. So first of all, since we're looking for the time between two beats, then we are basically looking for the period, because the period is the time that separates two waves. And recalling the formulas for beats, first of all, beats form when two sound waves of nearly same frequencies are emitted. So these are two waves of nearly the same frequency, and then a beat is formed. The frequency of the beat is equal to the difference in the frequencies between the two waves. So we can start by this equation for the frequency of a beat. Since we're looking for the period, then we can write the frequency here as 1 over the period. I will keep these in terms of the frequency because we are given the wavelength. We're not given the periods of the two waves emitted by the two pianos. And then we can rearrange this and write it in terms of the frequencies of the sound waves emitted by the two pianos. And now I'm going to substitute the frequencies by V over lambda, because in this problem we are given the values of the wavelengths of the two waves. And of course it's better to write these in absolute value because it doesn't make sense for our period to be negative. And now all we have to do is substitute to find the value of the period of this beat. So we're given the speed of sound to be 343, and the wavelengths are given for piano A, it's 0.769, and for piano B, it's 0.776. And if we calculate this, we will get 0.25 seconds.